Let's talk about periodic trends. I can usually win a good debate. Here's my secret. I use my knowledge of a good scientific argument to win. I lay the groundwork for the argument and then present it. What does this have to do with periodic trends? Well, everything. Let me show you how to construct an argument about periodic trends using ionization energy as an example. This is the energy required to remove an electron from a neutral atom. We'll make an argument for what should happen when we move across the periodic table and down the periodic table. In making the argument, we'll use both Coulomb's law and the shell model of the atom. Here's what we know. 1. Like charges repel, while unlike charges attract. So protons and electrons are attracted to each other, but electrons repel each other. 2. Interactions increase with the magnitude of the charge. As the number of protons Z increases, the attraction to the nucleus also increases. But, and this is a big but, this effect also depends on the number of inner electrons surrounding the nucleus and shielding its charge. So we will instead use the term Z effective to represent the charge after considering the effects of this shielding. 3. Interactions decrease with the distance between charges. This distance is related to the quantum number n of the outer electron. N increases, the outer electron moves further from the nucleus, and its pull towards the nucleus gets a lot weaker. So, how does this help us construct an argument? Let's take a look at the periodic table. As we move across the periodic table from sodium to chlorine, N is not changing. What does change is Z, the charge on the nucleus. This nuclear charge is shielded by the outer electrons. But as we move across, we are only adding valence electrons, and these are not great at shielding the nuclear charge. So Z effective increases quite a bit as we move across. This means the attraction of an outer electron to the nucleus is increasing. It takes more energy to remove an electron, and the ionization energy increases. Not bad. Let's try moving down the periodic table from oxygen to tellurium. Now, we need to consider changes in both Z and N. We'll consider Z first. The charge on the nucleus is increasing, but remember, we have to include shielding. The number of inner electrons shielding the nucleus also increases as we move down the periodic table. And inner electrons are great at shielding. So there's actually only a small change in Z effective. Since the changes in Z effective are small, it is N that rules the day. As we move down, N increases and the outer electrons are further from the nucleus. This increase in distance means the attraction to the nucleus gets weaker, and it is easier to remove the electron. So, ionization energy decreases. Those are pretty good arguments and pretty good predictions. Other factors can sometimes come into play. The subshells and electron pairing can sometimes matter, but don't sweat the details. Just start by paying attention to Z effective and the principal quantum number N. With those alone, you'll do pretty well in any debate about periodic properties. Now you know.